So today we're going to be talking about a tool that Michael and I wrote. It's about essentially automating away the process of finding cross-site scripting on a pen test. Just to get an idea, does everyone know what cross-site scripting is? Are there people that don't? Okay. Yeah, it's just like when you get essentially code execution, but not in the scary sense of like the last talk. It's more of like JavaScript code execution on a browser through someone else's domain. So usually that allows you to control the domain maliciously, which is can often be pretty bad if there's a lot of data there. Yeah, so this talk is going to be shortened just like the other talks, but we want to kind of go through a couple of things why we wrote a tool. The first reason that we kind of had this goal that we wanted to eliminate cross-site scripting. It is this really old bug that's been in everyone's pen test. Essentially, on every web app test, we find cross-site scripting, and it's easy. It's prolific. It's in every single web application, and it's super dangerous. But we, like it's kind of boring to find. Like I don't want to spend my time looking for cross-site scripting. There's all these new cool web bugs like single sign-on and SAML and all this other like fun and interesting like cross-tenant access control things that I'd rather look for, and are often more dangerous. But we still need to give the time of day to cross-site scripting. So we would like to kind of like make a tool that automates a lot of the process away. And we want to do this in a special kind of way. We don't want to do it. We want to use essentially the DOM to help us. So the DOM is what actually renders all of the scripts in the page. And it has all the data that we need in order to get an idea of like where scripts are loaded, what types of user input is getting written out to an output. And so we want to take advantage of that large amount of data and not really introduce anything else. The other thing that we wanted from this tool was we didn't want it to be super automated. We wanted a lot of our workflow to be automated, but we wanted the control of the tool to still be with the pen tester. We wanted human interaction to guide the tool, find those sources of inputs, and then essentially the tool would do the rest of the work. What we don't want to do is create a tool that has a lot of buzzwords in it. We don't want to use like AI. We don't want to use machine learning or automated scanning. This is not a static analysis tool. You cannot just run this as part of your pen testing flow and it will automatically find you bugs. It is just something that essentially will automate a lot of the time suck that you usually spend when you have to find and verify and locate these bugs.
All right, before we talk about how Tracy works, let's talk a little bit about the existing methodology and tools. There's really three categories here. There's manual testing, static analysis, and other. Other is kind of where Tracy lies. I'll talk more about that. But first, manual testing. So like whenever testing web applications, a lot of times you find XSS, you just kind of spam a payload in all the boxes and hope that an alert box pops up whenever you browse the website, which is great. It's quite easy, but it has a problem, and that is if there's any kind of encoding, it's going to break your payload. And also, sometimes the alert box pops up, and then you don't know like where that alert box came from. Like it could have been in an input box like 8 pages ago, or on even another website. You won't really know that unless you can do clever stuff like put like different numbers in your alert boxes or whatever. But then it gets hard for you to track like where that input was originally from and stuff like that. So that methodology can kind of get complicated. Then there's static analysis, which Burp has like a built-in static analysis, which is like an interception proxy that other people have talked about today, where whenever you're browsing the website, it'll look at the JavaScript and try to determine if there is any kind of exploits within that JavaScript via like breaking it down into like flows of like this thing can get input from like a URL parameter, and then it sees like it outputs it here. So maybe this could be like a vulnerability. Lots of times whenever I've seen this in testing, at least in my Burp, it's never actually been useful. It's always been false positives where it does some kind of logic to actually filter out the strings or whatever. I've never had a static analysis hit that was actually a legitimate vulnerability, but maybe one day. So the last thing, other. So there's like this category of tools out there, they're kind of mysterious because they don't really describe how they work. It's is it like Blue Coat? Yeah, and Phantom.js. Well, we know how Phantom.js works, but like Blue Coat, like they just have like a whole bunch of buzzwords on the website, but they're really cryptic about like how it actually finds like XSS through the application. And without paying money, as far as we could see, we couldn't actually test to see how it actually worked. But what we think how it works is they actually fork like a browser like Chromium or Firefox, and then they add in like C-level hooks to certain JavaScript functions, so that way they can actually trace, like do taint analysis on user input and stuff like that. But the hard part with this is that it requires a lot of effort to like keep it up to date with like how like browsers are moving really fast nowadays, adding tons of new features. So you have to like go through and re-add in all those hooks and find out like which functions are now dangerous and stuff like that. We don't really have to deal with any of that with Tracy. We can just whenever there's an update, it just works because it's a Chrome extension and not. Oh, you left in all these slides. Maybe I should have went to all of them. So let's talk a little bit about how Tracy works now that we've looked at some of the competition that we have to go up against. So there's really three main components of Tracy. There's the mutation observer, which is part of the browser extension, and then there's the proxy/API server. So how this works is that the way that Tracy works is it's a not Burp extension. It's a Chrome extension and a Firefox extension. Really, they use the same APIs. If you guys didn't know, you can interchange them, and it'll work just fine. Because originally we wrote it for Chrome, and then we're like, will it work on Firefox? And it happened to work. So the way that this happens is it monitors the DOM using the mutation observer API. I don't know if anybody else has ever seen this before, but the way it works is you can actually hook it onto a certain DOM element, and anytime that there's a modification to that DOM element, it will actually trigger an event, and it will tell you what was changed inside that DOM element. So by using this, we can look at like where user input goes into the application, and then use the plugin to hook the like top level DOM element and look at all the mutations that are happening within inside of the application. And then whenever there's that mutation, we check to see if that user input is in there, and then how it's reflected back to the user to determine if it's like vulnerable XSS. So let's go with some workflow example. So this is like Google Gruyere. It's a purposely vulnerable website that you can test out. So in this example, we are creating a payload. Like there's this Tracy icon here, which allows you to create like a menu, and then you can say like what kind of payload you want. In this case, since it's a username, there's probably sanitization checks to make sure that there's no like weird characters. So we're using a plain payload, and then we can enter a password too. And then once we browse the web application and we see that payload come back to us, we can see here in the Tracy UI, which is like a web interface, where that input was reflected back to the user. And then anytime there is reflected back to the user, there will be a list. And so we use this information to be able to find XSS within inside the application. This is done via some trickery. We abuse the browser logic and use concept of like DOM mutation, not DOM mutations, but like DOM clobbering, where if your HTML is not perfectly correct, the browser is really nice and will correct it for you. So what we do here is we have this double single quote and then this tag element. And then whenever we inject that into the page, it's going to turn into certain kind of parameters. So it's going to end up in like certain locations. Like in this case, inside of Google Gruyere, it ends up inside the attribute name. And I don't know about you, but I don't think my user input should ever end up in an attribute name of a tag, which is like a dangerous spot, because then you could use like on air or anything like that. Also, the important part of this like tag part is that if it ever becomes a tag name inside of the application, we also know that there's XSS. Oh, I didn't realize. Down here you can see that it's the inputs this tag has become an attribute name. So that's pretty much how Tracy works. It just checks to see where the user input is outputted back to the user and checks to see how it was outputted back to the user, whether it becomes an attribute name or if it becomes a tag name, or if it got injected inside JavaScript, or if it was on like an on-air or anything like that.
Thanks. Yeah, so we're just going to quickly kind of run through a demo to see how you might use this on a pen test and how Tracy will alert you on vulnerable instances of cross-site. Okay, so this is another like a fun game that Google has. It's like an XSS game, so it's like each level has a different type of XSS. It's really nice to test Tracy with because there are many different types of cross-site scripting, but we want to make sure we get them all. So there's like reflected and stored and DOM and all that kind of stuff. So we're just going to quickly show. I've already got it installed, so you can see the owl there. And I've got the UI on this side over here. So we don't really have any data. I'm just going to zoom in here a little bit. It'll kind of mess up the UI. But the thing to keep an eye on is on the left here are all of our injection points. So this will be a table of all of the user input into the application. And then this will be like a kind of a detailed view of the thing that you click on here. And then on the right side is all of the outputs. So anytime, so an output is something we consider to be like a write to the DOM, a call to inner HTML, a call to eval, a call to set interval, an HTTP response. We have a lot of signal in this area, and you can use that to essentially trigger vulnerable cases of cross-site scripting. But that's how you should see it. So on the left is injection points, and on the right is observed outputs. Okay, so let's get this started. So I happen to know that this first example is pretty easy. So you have it like some kind of input here, and you can just hit search, and it pops up in a query parameter. And oh, we can see that that user input was reflected back to the user. So this is pretty much going to be a case of reflected cross-site scripting. So to solve this, you just need to trigger an alert box. But I'm not going to trigger this alert box. I'm going to actually just show the workflow for how to use Tracy. So you can right-click here, and you'll get like a little Tracy menu. And these are like the different payloads that you'll use. So Michael kind of already brought this up, but we have genplain, which is just a 10 alphanumeric character that Tracy can remember. So whenever you use that payload, Tracy will always remember it. Whenever it sees it in the DOM, it'll like keep a flag on it. But the other one that's cool is this gen XSS, which will generate like this polyglot for you. And the identifier in the middle is also remembered, but it happens to have these like meta characters on it. So if we hit the search button with this one, we'll see that, we don't see our other payload. It's kind of like hidden, and that means probably likely that the DOM was broken. So if we go back to our inputs over here, oh, cool, we can allow notifications. How cool. So on our input side, we have this gen XSS, and you see it's already recorded this OGVIEIY, blah, blah, blah. And it's marked as severity 3, and that's because it knows it to be vulnerable to cross-site scripting. So we can see it was issued via this GET request as this query parameter. And then on the output on the right side, it was discovered to be in a node name under the B tag. So you can see user input got set as a node name. It's under this B tag, and this was the DOM write. So you can see like this kind of stuff. So as Michael described, user input should never be a node name. That's never going to happen ever. So this is going to be a known vulnerable case. And so now that we know how the DOM breaks in this special way, we can craft our input. This. On there. Oh, awesome. Great. So that's like level. So that's reflected input, and you can see how Tracy would be really nice to find these kinds of cases. the really cool case that Tracy is good at is DOM-based execution. So like, suppose there is no GET request that sends off your user input, and your user input is actually just taken and then put in back into the DOM. Since we have this mutation observer always watching, we get all kinds of feedback about if that user input is ever executed. So again, Tracy's kind of marked this text field as like, oh yeah, you should check this out. So we can click this and we can do our gen XSS. And as soon as we generate a payload, it shows up in our little field. Okay, so yeah, so this is another case. Oh, cool, a notification. So again, we have another case where it shows up in our user input, and then on the output, we have the two different areas where these are two different events because there was a DOM write, and then we also do this cool thing where we actually hook inner HTML. So anytime you use inner HTML, which is like a super dangerous function you should never use, we'll get an alert on it. So whenever they used inner HTML, they actually wrote our user input as this HTML flag, and that's why we got the severity 3. Yeah, so again, quickly go through this. Okay, cool, sweet. So now we can do reflected and stored. The other thing that's worth mentioning is that like I haven't really changed my pen testing flow. I'm normally going to be clicking buttons and typing in text fields. Like Tracy kind of like seamlessly integrates with my flow. I just have to click a button and it automatically fills the payload, and Tracy kind of handles the rest. Okay, so this is a neat one where they use inner HTML again. This little hash we can kind of see. If you look at the code, it's a little more telling. But in this case, they use the jQuery.html, this tab content.html, and that's just it's a wrapper for inner HTML, and it takes user input of the num and evaluates it. So what I can do is again generate a Tracy payload. Okay, broke the DOM, great. And then oh, great, an alert. So cool. So we get these nice little like events that show exactly how we broke the DOM. We get an event that we are in the inner HTML, and we can essentially create our attack payload. Oh yeah, what is it?
30 inside of an image tag.
That's right. Just writes out of a single. Okay.
Hey, you don't have to close the tab.
Oh, awesome. Okay, last one. So this one's a little more challenging. This one happens to use an onEvent handler. So if we look at this JavaScript here, oops. So the vulnerability happens here. So on load, a timer gets started, and this is a JavaScript that gets evaluated, and then it replaces timer with a user-controlled input. And so this is escapable because we can, use a quote and then execute our own JavaScript or whatever. But Tracy happens to know that onEvent handlers are super bad. So if your user input gets landed inside of an eval statement like this in this onEvent handler, it'll figure it out. It's a little harder to prove that it's vulnerable in this case, so it flags it as orange, but still worth looking at. If you just click the output, you can see exactly how your user input is inside of this onload handler, and then the pen tester can go and make their okay, great. So those are 4 levels that we kind of just like quickly did just by clicking a button, and it gave us a notification that there was a vulnerable case of cross-site scripting. Yeah. Wow, this is a really cool tool. Okay, so what can we do? Just a summary. We can't really eliminate all cross-site scripting. It's going to always be a problem. But we hope that this tool will essentially decrease the barrier to entry so much that QA teams and bug bounties can just essentially click a button, find cross-site scripting, and essentially the low-hanging fruit will get pruned away so quickly that it won't feel like it's actually a problem. It can map all inputs to outputs. It uses the DOM. It can automatically kind of like discover vulnerable cases of cross-site scripting. And soon that we'll have like automatic reproduction steps. So since it carries so much information about the DOM, where it was, where it started, we can essentially use that information to recreate the finding and automatically show, like instead of me having to type image, it can go and fuzz that front end for you. This is a project that we work on, just kind of the two of us in our spare time. We would love some more help. If people want to help out, please send us a Git PR. There's one more thing, like we have these next commits coming. So front-end fuzzing, verification of cross-site scripting, and automatic reproduction steps are very close. I didn't want to push it. Otherwise, I knew they wouldn't work in the demo. But so stability is obviously a thing that we need help with. And then we also would love to get more like a signal with our outputs. So we want to hook more JavaScript functions. Right now, we're having a really difficult time hooking eval, but that would be really cool if we could see anytime someone evaled JavaScript with user input, because that's almost a guaranteed case of cross-site scripting. Yeah, I don't really tweet, but you can tweet at me and I'll respond to you. But there's the link, so please come help. Thanks.